Hello, I'm Paul Parkinson.
And I'm Mark Nelson.
We're architects for a large microservices transformation project, and today we'd like to share some of our experiences with you.
We initially struggled with things like how large to make services, how many services we should have, and how to draw the boundaries between services.
Yeah, in the beginning, we let each service team choose their own frameworks and tools, which has its advantages, but we quickly realized that made dealing with cross-cutting concerns very complicated.
Yeah, we really learned early that creating standardized ways to handle things like authentication, vulnerability handling, service discovery, that really simplified the whole project.
Right. And when we implemented standard CI/CD DevOps pipelines to automate building, testing, and deploying containers, it also had a huge impact.
Working out how to split up the data in our monolithic database was a big challenge. We used a tool called Data Refactoring Advisor to help with that. It looks at the actual usage patterns for the database and uses graph algorithms like InfoMap to identify clusters.
Yeah, we also standardized on the Spring Boot framework, which meant we could create project templates that embodied our best practices. That really helped new teams get up to speed quickly. We use the Spring Boot starters from Oracle for things like connection management, messaging, and event streaming. Having standard dependencies really helped reduce bugs and simplify the vulnerability management and compliance.
At the start, we wanted to do things properly, and we really got into patterns, especially the database for service pattern.
Yeah, we let each team choose their own database, but that turned out to be a nightmare. We ended up with about 10 different databases, and of course, they all had different installation, management, patching, etc. And we couldn't share our compute and storage resources between them.
Yeah, and we also had huge data duplication. It was horrible. We were copying data all over the place, and we had to deal with different formats and APIs. It became really almost impossible to keep track of it all. When we failed a compliance audit, we knew we'd made the wrong choice and we had to change course.
Yeah, most of our core systems, or legacy systems, you may refer to them as, used Oracle. So a lot of our most important data was there. We adopted Oracle's multi-tenant architecture and used pluggable database containers to create databases for each service or group of related services.
Well, we saw improvements right away. We saved heaps of time on DBA tasks and lifecycle management. We were able to share resources between databases, and that really cut down our cloud spend.
And we were able to enforce consistent configuration and security policies. So we would dramatically reduce data duplication. And I can't overemphasize how much that helped us to meet our compliance requirements.
Of course, as soon as you have more than a few microservices, you're almost obligated to implement the Saga pattern to manage data consistency across all those data sources.
That's right. It's one of the most complicated data issues that microservice architectures face, in large part due to the need to implement compensation logic, which is why we use the MicroTX Saga engine along with a new lockless reservations feature in order to have auto-compensating transactions. And that was a huge win.
Of course, with every solution comes a new problem. And the next challenge was that all these microservices were putting a heap of load on our operational databases. And that really impacted our overall system performance.
Yep, exactly. We deployed Oracle True Cache to solve that problem. It allowed us to create read-only caches close to the applications that are automatically kept up to date and consistent. We were really able to offload a lot of query workload to those caches, and we also saw good performance improvements.
Yeah, and the fact that TrueCase supports both SQL and object access is great. That meant that, we didn't have to rewrite services that use document APIs in order to adopt the cache.
Inter-service communication was another key challenge. Of course, we started with REST like everybody, and we dabbled with gRPC, but we soon realized, like many, that we needed to use an async event-based communication style. And so we implemented that with Kafka.
Yeah, and like a lot of people, we had challenges scaling and rebalancing. And we found we were writing a heap of code to try and detect infrastructure level issues like out of order message delivery and implement logic to handle those issues. So we ended up with idempotent producers and consumers and really just a really high level of complexity in our code.
Yeah, we really wanted to focus on the business logic. This is one of the key strengths of microservices, and not spend time handling infrastructure challenges. And we wanted really reliable, exactly once delivery and transactional semantics. My background has always been in transactions, so I really appreciated that aspect. So we actually migrated from Kafka to Oracle transactional event queues, which was great because it let us implement the transactional outbox pattern really easily with full transactional consistency. And we eliminated a ton of error handling in the code, simplifying everything as that error handling code was no longer needed. And the other bonus was that transactional event queues are actually compatible with Kafka APIs. So we could even bring over Kafka code as is and still take advantage of the transactional aspects of transactional event queues.
Right, and of course, we go on the observability train. You pretty much have to. It's just essential in a microservices environment to know what's going on in the system and to be able to detect and diagnose issues, and for performance tuning and capacity planning.
Yep. So we use the extremely popular Grafana stack for most of our environments. So we really love that Oracle Database Exporter allowed us to get our database metrics in that standard Prometheus format. And we could easily define very custom metrics at the application level too.
Yeah, and the open telemetry support in the Oracle JDBC library is great too. That let us see the queries that were being executed when our services reached out to the database. And being able to see application level metrics alongside Kubernetes and Oracle metrics on a single dashboard is just fantastic.
Yeah, exactly. And testing is always crucial and always involves a challenge, right? So Mark is definitely the testing guy.
Yeah, that's right. I love testing. And there are actually some really great things we learned along the way. In the beginning, we were using in-memory databases like H2 to run our unit tests because they were so fast and lightweight. But we kept finding little idiosyncrasies and inconsistencies. When Oracle Database 23 AI Free was released as a container image, that was a game changer for us. That made it possible for us to test against a full Oracle database, the exact same thing that we use in production.
And for integration tests, we were able to use the Oracle Database Kubernetes operator to provision Oracle instances and clone our desensitized data into our DevOps pipelines, which we run in Kubernetes.
Both of those things helped us find issues much earlier and save us a bunch of rework.
Now, our legacy systems were mostly written in PL SQL, so we had a lot of data and functionality in Oracle that we wanted to access from our microservices.
Initially, our developers were calling PL SQL from JDBC, from Java code, but that was a real pain to lint and test, and the error handling was really cumbersome. It was further complicated by the fact that most of our developers had very little PL SQL experience.
Yeah, we used Oracle REST Data Services, or ORDS, which lets you easily expose any data and functionality in the database as REST services. So then the developers were able to just use standard REST clients, and the code was way easier to write and test.
Yeah, and so another key challenge we had was dealing with documents or JSON data. A lot of our developers, especially the newer ones, didn't have as much exposure to relational databases and really preferred to work with a document-based interface.
Yeah, of course, like everyone else, we used Mongo in some services, but we had a lot of issues with data duplication due to the denormalized storage format, and that caused very slow updates.
Yeah, using data from multiple collections was a problem too, since there's just not a good join feature in Mongo. We also had to spend a lot of time managing the shards to try to maintain good performance.
Yeah, at one point, when we started using a lot of indexes, we ran into huge issues with write latency.
Yeah, and of course, since all of our master data was in Oracle anyway, we had to create a heap of data duplication to use Mongo in the first place.
Yeah, so we were really excited by the new JSON relational duality feature in Oracle Database 23 AI and the improved JSON collections. So JSON duality views let us leave our data in relational tables with much more efficient normalized storage, fast updates, and full ACID support, but at the same time expose the data to developers as JSON documents. So you get the best of both worlds.
Yeah, and for services with relatively simple document structures, we use the JSON collections in Oracle to store them. So for a lot of those use cases, we could actually just keep using the MongoDB API, but point the services at Oracle instead of Mongo. So we were able to do that with almost no code changes at all.
The emphasis put on features that simplify the hardest problems with microservices, and especially data-driven microservice, really shows, especially in this latest release of the database.
I hate design complexity, bounded contexts everywhere. I hate the database per service pattern. Inconsistent data is a nightmare. I hate data duplication and read-only data cache. I hate inter-service communication and idempotent everything. I hate how hard it is to know what's going on. I hate how hard it is to test. Eventual consistency is such a pest. I hate how hard it used to be to use existing functionality, even with JSON duality. But microservices aren't so bad. Not anymore. Not with Oracle. Not at all.